So these are recently powder coated casings. Put them together. The reason for this being, we're going to check them for square. Part of the powder coating process is ovens, and we need to check that there's no damage being caused to the casings. So there's a number of ways we can do this. We can either use marking blue across the face and then use the surface table, or a lot easier is just to put a rule across and use a feeler gauge in various points. This is especially important when it comes to the oil pump. We need a good mating face there. Appreciated there is a gasket there, but we still need a good mating face. This engine has suffered quite heavily from the British roads and road salt. And you see here there's a lot of damage being caused where it's been used as a field bike or just simply salt has been sat on there. So it's very important that we get this mating face correct. So once you've checked it for squareness, you use a stone. This is a stone I only ever use for castings after they've either been machined or just to check for sharp edges and high points. Again, you would do the same, put your steel rule across, check your feeler gauges, just make sure they don't go in, make sure your stone's nice and square. So lightly applying some oil, just gently go across the casing. You're not looking to machine this casing with this, so go easy on it. You're only looking for high spots. Okay, and to make sure it's a good mating face all the way around. You want to go across and across that way. Just look at your figure of eights. Never use it just on the edge. Always make sure you go across like that or like that. Keep the stone as supported as you can to stop it digging in. The same on this face. I've finished this face and you will see there's lovely swirl marks in it, very light. What you see is touching all areas all the way around the casting, so we know that's nice and flat. This particular area was very pitted. You've got to be careful that you don't start digging in with this, because you're going to alter the angle of the bore, and then you're going to get all sorts of trouble with piston wear and start taking the sides off the skirt and wrecking the bores. So all you're doing is looking for a face all the way across. So as I said, the road salt really affected this area. And there's nothing left of the original exhaust in this area, and you may remember, those who are following the bike build, the amount of rot that was on the inside of the frame. So going across gently with the stone, you can see we do have a mating face come. This thickness here is sufficient for the gasket we are using, so we've got enough now. I'm just going to continue just with a light stone, just gently across, just to make sure we get a good and that should be more than sufficient. We've got an O-ring that goes here. We need to unblock this oil gallery should it be blocked, and we're going to use some welding nozzle cleaning rods. So you see we've got a good face all the way around now. So we're going to split this casting, clean it, and then start rebuilding. There's your oil pump housing, and you'll see the outlet from the pump goes into here and then is forced through that small hole there. So it's important that we make sure this is clean all the way through. Now what's important here is you clean it out to its right size, not just one that's close. So this is where welding nozzle cleaning tips are perfect. you don't take this out enough back to its original size, and it will starve the top end of the head, cams, valves. Take it out too much and it may give insufficient back pressure to feed the top end of your head, and also may starve other areas of the engine from oil. So it's important you don't mess with that. Keep it the size it is, unless of course you're into modifying your engines and you're running high lift cams and God knows what else, cross drill prams and those kind of things. But all we're doing is taking this back out, cleaning it to its original size. So these are the initial parts we're going to start with. These spindles haven't yet been cleaned, but I'm going to go through what they are. This is your kickstart. You'll see how when this is kicked, it engages and disengages this gear. And that's basically how your bike starts. There's the kickstart spring, and then the return for the kickstart spring. This is your gear selector, which I'll show you in a minute how it works. And this simply counts these as it goes past, which I will show you in a minute. And there's the return spring for its stroke neutral position. Those are the keepers for it. This is a good opportunity to see how this works. So this sits between your gears, and you'll see how this moves. It's there, and it's on a cam mechanism, and you'll see both of them move up and down this shaft. I'm doing nothing, and that's how your gears are selected. When it's all together I'll show you how. Here's your different things, your lay shafts, your idler gears, simply in and out of engagement. There's your first and second. They go from one side to the other. Like I say, when it's together it'll be easier to understand. I'll go through it again. This is your cam, your drum, as described earlier. You're looking for play in the fork selectors here, and you can see there is very little in here. Should I have suspicion of this, I would take these apart. There is very, very little that way or that way. Just as a quick guide, get to a worn section, so roll the arm across, and you've got 1.33, and the service limit on that is 13358. We're running at 13365, so that's well within its service limit. The thicknesses of the forks, here we've got 0.232, and you're allowed 225 on the right hand. On the left hand you're allowed 0.1811, and we're running at 0.196. So that whole assembly there, the whole cam assembly is and the fork selector forks is in very good condition, so I'm happy for that to go straight in. That little tab there is for your neutral switch. Okay, and that is where your neutral switch goes, and that simply touches that, creates your earth. Good old fashioned crude way of getting a neutral switch. So yeah, make sure this is undamaged, it's slightly proud like this. If it isn't, or your tab's damaged, just renew it. You can still get these. So this one here is called your main shaft. You can see you've got This is where your selector goes here, well, the one selector anyway. I'm not going to take this apart. There is no play in this. There is no reason to suspect this or need to require to measure this. And really you need to look at the diagram yourselves to explain this, because you've got circlips, shims, another circlip. But this is called your main shaft, and this one goes into here. Once the shaft is in, it has a little shim on the top. Be very careful with these shims, because there's a few of these in the engine that are very, very, very close on size. So simply have a jiggery pokery amongst the shafts and see which one fits best. Just be careful you don't get the wrong one. This one here is called your counter shaft. Again, this is where the selector fork goes, and it engages and disengages with this gear here. It is best that, again, you see the diagram yourselves, but this is your final drive. This is where your sprocket goes. You have a series of circlips. You have a spline washer. Then you have this gear. Check the gear, the dogs, for wear. This is pretty good. Then you have a spacer, and then again we have another shim, and this goes in there. When you're ready for the cam, take the gears back out. Bearing in mind you've got your shims in here, your spacers, make sure you keep them all. That one there. Assemble it like this, so you can see the selector forks have gone in to each of their running slots. And then carefully drop it in. So it should look like that once it's in. Okay. Put your selector pins in. You notice one's higher than the rest. This is to stop the selector continuing to go around, damage the selector. This is your selector shaft. Goes in there. Ensure that you get that in line with the spigot that's on there. A chap contacted me via YouTube that when I was rebuilding the gearbox of this engine, could I explain how the gears worked, because he couldn't quite understand how it goes together. I believe he's building an ST70, something like that, and apparently similar engines. So I'll do my best to explain it. It's hard if you haven't got it in front of you to understand, but if we call them input shaft to the gearbox, which is actually where the clutch goes, crank and then onto your clutch. So that's the input to the gearbox section, and then the output is that shaft there to the sprocket. Okay. So currently this engine's in neutral, so that's spinning round, which is your clutch from your crank. That's spinning round, and as you can see this one isn't. This gear here is permanently fixed to that shaft. Okay, they are as one. So that's your only solid collection there. This shaft here, the output shaft, has no actual permanent physical connection to the shaft. It's all done by splines, okay? Whereas that one there is an actual part of the shaft manufactured from the same item. This is connected via splines, okay? Now, what's connected from there to there directly is only this gear. This isn't connected, that one isn't connected. These just freewheel, so to speak, on that shaft. This is the only one that is connected to that shaft. So it must be driven through here. Okay, so as you see at the moment, these are spinning. It's only because they're driving off this one here. They haven't connected to this. So this at the moment is neutral. As I said, this is your selector fork. So what will happen is here, you will kick this, the other side down, sorry, that side. You will kick that down and that will move that selector across. So that's full travel of that selector now. That's pulled that over as far as it can. To there. When it's released, it clicks back onto the next one. So this now is in first gear. And we can see we've got drive. What it's done is move this outer one across and engage this, which was a physical connection with that shaft via a spline, into this. The teeth are now touching this, the little dogs on the gear. So we have a drive here, quite a high RPM to a very low RPM. This is first gear. We then move it again to the next one. Which is here. This is engaged, this fork, all the way back and into the rear. Tough. So now we have a drive from the crank, driving from there into there, which is dogged into that. That, remember, is the output of that shaft. So we can see it's harder to turn, and that is near enough, I would say, 1-to-1 ratio, one turn of here to one turn of there. So again, the selector fork would move across and it would pick another gear. So that would pull all the way across there, like that, and that would select your gear. You can't then select another gear because it won't be allowed to click up over the pivot. So that would never have enough stroke to come and grab that one. Okay, and that's how you can't go into neutral again, or a fourth gear, should there ever be one, because there ain't one. Okay, so here now, very hard to turn compared to how it was. And I would say that is slightly above 1-to-1, possibly 1.5 turns of that to one turn of that. So we are going from the crank, we're engaged on the back gear still. That's driving the back gear on there and is forward through and is driving through the full train now. So we're going to here, to here, to here. And that's maybe the best way I can do it without actually seeing it for yourselves. So I'll try and go down through the gears if you watch through that side. So neutral, first, second, and that's third. So third, second, first, and then neutral. Boss goes on towards the shaft, so it's boss first as opposed to that side first. Thicker side, okay, thicker side, shaft goes this way, not that way. Your kickstart shaft, it's just this spring here provides just restriction. Other than abuse, the only thing I've ever got with a kickstart is these springs snap or become weak, and it doesn't let the gear travel along the spline. So it engages on that there, and it simply slides up and engages on the gear, that one. Just quickly explain what I've done here. I'm not keeping this piston. Okay, the piston was left on there to protect the little end. I'm not keeping the piston, the rings, the gudgeon pin, nothing. That's all getting renewed. I didn't split the crank because I do not have a jig or want to make a jig that will ensure this goes back together correctly. There is no play in that bearing at all, in the slightest, and it'll be more trouble than it's worth. You've got to get it square in every way. It's a press fit, it's probably heated up and pressed in. It's just not worth embarking on that when there's no trouble with it in the first place. So to get it apart, I heated with MAP gas. I didn't use my oxyacetylene or oxypropane because I wanted to put very little heat into the shaft. I used a soldering mat for pipe work so we could concentrate it on the outer stroke to the bearings, and then hopefully the heat will propagate into the inner race. We don't want to heat the shaft. So we didn't know there's need those bearings, so it was just a quick burst, round, get it hot, tap them off. You need to sharpen your crowbar to get underneath here. What you don't want to do is whopping great big extractors and you got the risk of bending this. So I went for the pinch bars, just gently lift it. It doesn't require a lot of force. If you do it evenly and they're hot, it will pop off quite easily. Although it looks crude, it is a good way of doing it. You don't want to put any stress through the centre of here. You don't want to push down on here and start squeezing the cheeks of the crank together. Just little force on this as you can, especially when it's just a thin pin like that, which is a press fit. So after that, I did the same on that one, same side with that. The bearings, the crank was cleaned and cooled in a freezer for 1 hour. Okay, the freezer is about 18 degrees minus, and it just sat in there for an hour. So that was the crank cooled. The bearings were heated up to 120 degrees in the oven. Not so you're burning the grease, not so you're damaging the bearing, just gently in an oven, 120 degrees, along with the cam sprocket. What you need to make sure of is when you take the sprocket out is that you get the teeth alignment the same. I know it's only a small tooth against a large wheel, and very little difference on here will make very little difference, even more so up the top due to the bigger wheel, but it is important, and you will affect the performance if you get it wrong. How much by, I don't know, but all I did was add a little Sharpie marker that I knew that the valley of the gear lined up with there, and that's it. And then just gently tapped it on, allowed it to cool, and now nothing is moving at all. Everything spins beautifully, so we haven't overcooked bearings or damaged it in any way. I'm going to put it back in at the moment with the standard piston that come with it. Like I say, it is getting stripped off, but at the moment it's protecting the piston and the little end, and that's what I wanted to use it for. It is getting scrapped. This is the oil pump. I've took this apart and cleaned it all. Light stoning. Be very careful cleaning these faces up, because the clearance across there is very important. There's a certain amount of wear allowed, stroke loss of oil. It shouldn't be flush, because you need a film of oil to go across here to give you the lubrication for the pump and also the sealing effect. If it's took away too much here, you'll not only jam the pump, you'll also pick up on the aluminium too much and it will pass as well. So be very careful with that face, what you're doing. There are ways you can save these pumps by grinding this back. I used to do it when I was an apprentice, repair these pumps, and when the company was too tight to buy them, we'd grind these faces back and then bring the sides down flush again, to restore the pump really. So how this works, it takes from the low pressure side, which is here, the strainer would be here, which is currently coming through the post, and low pressure side across here to the high pressure side, and then it will go out through that jet that we cleaned with the welding nozzle here. I'm not going to tip the engine up because I'll start losing stuff, but it will force here and then force through the block and up to the cams. So if we flip this over, there's your low pressure side, this is your inlet to the pump, that's your outlet, which is there. And how it works, it will take from the inlet, so oil is coming through that hole now, coming up through here, it will carry that across and then force it as it squeezes that hole back down, force the oil through there. These are very good high pressure pumps for what they are. The PSI you can get on these is quite impressive. So that's how that works. So you'll see this is called the rotor on the outside. It was when I used to repair them. That was called the rotor. And what you need to do is check for the clearance here. Now on this pump, which I was quite surprised at, you're allowed 8 thou, which I thought was a hell of a lot, and it's far bigger than what I was used to in the past, but this pump's perfectly fine. Okay, so that's spinning quite happy in the housing. That's all good and ready to go. You also need to check across that face there by putting a steel rule across and measuring with a feeler gauge in there, and that's 4 thou, so 4 thou, so yeah, it's quite a lot really. So we're going to put this together now. Give the drive shaft a little push as you give it a little bit of a rotate with your fingers underneath, so it keys in to the drive shaft from the cam chain, and now you'll see that's driving. Do that before you lock any parts up to make sure it's all happy, and be careful when you let it go that it don't fall back out. Alright, we've had a little setback. The gasket kit didn't contain that, which goes there, so it's delayed us a little bit, but I'm used to it now with these builds and finding out stuff that's missing and not missing. So we'll put together what we can, but we're going to have to leave this free, so no big flywheels over there. So let's crack on with what we can. Little spacer collar there. After the little spacer you got a bush. And then the gear, I mean, that's really, look, still got the original honing marks in there. That's really impressive. It's a new piston, standard one, because the barrel was so good. You'll notice an arrow on the top. The arrow points downwards towards the exhaust. Installing the piston rings. You've got your oil ring, and then your two rings, which although appear identical, they're not. You've got a top ring and a middle ring. So we'll start by putting your oil ring on. You'll see this has got, let's have a look here, no markings on that ring, and the profile is the same either that way or that way. Both sides are the same thickness. To put the ring on, you've got to make sure that you don't scratch any marks on this piston, the skirt at the bottom, or damage any of the profiles. So what I tend to use is a piece of shim steel. And you see, doing it this way, there's absolutely no damage at all caused to the piston ring or the piston. Shim steel won't be much good afterwards though. This is your second ring. When you get pistons like this, you can always tell which ring goes where without even looking, because all the rings are different sizes. So that's quite a nice fit in there, and that's a very sloppy fit in there. It's a much better fit there, and far too tight to fit there. With the second ring, there's a wedge shape effect on it. Okay, and the top of the wedge on this piston ring will go that way. And there's a little letter on the top of there, if you'll focus. Well, there's a letter R on there. There, I think you can just about see it now. And that goes towards the top. All the rings are now on. The top ring's the same both ways, but it does say that you should put the markings upwards, so I've just put the markings upwards, just another letter R pointing upwards. So all the rings are on, all the gaps are in line, which is incorrect. I will go through ring spacing in a minute once we've got the studs in and we know we haven't knocked it in. We're about to put the barrel on and all the seals are on. So at the moment I'm going to leave them like that, and then we need to space them 120 degrees apart. we're about to put the block on. I have used a small amount of Loctite MR5922, which is a gasket paste, a very good non-hardening one. It isn't a substitute for a gasket paste, and I wouldn't normally use a gasket paste, but as I explained earlier, when you see the poor condition of the surfaces around here, although they stoned up flat, I want to give this every chance of sealing. So I don't like using it, but I am going to use it just for this gasket. I've spaced the rings, so the oil one is about here, the second one is here, and the third one is about here. You're not allowed to have ring joins there 90 degrees to the pin. That's not a good idea. Ideally you're aiming for about 120 degrees apart. Okay, so that kind of separation of rings, and ideally do your bottom one that one, your second one there, and then your third one's got to travel all the way around. So aim for about 120 degrees, but nothing 90 degrees to the gudgeon pin. When you've finished lapping the seats in on the valve to the seat, you should have a matte band all the way around. Now, depending on your head configuration is how that matte band should look. Some of them, if they're too wide, it means your seat's worn, because there are various angles in there as it comes in. So you've got your typical valve, it isn't that all the way down, it's actually a series of angles at different points, and it's best to refer to the manufacturer's information on this. But what you're looking for is a matte band, if this comes out okay, a matte band all the way around, and you'll see there's no pitting. But what you will see is that that matte band doesn't go all the way to the seat here, and it doesn't go all the way to the edge. You'll see a shiny finish just before the end. That is a good ground valve, and it's not an overly worn one. When they're worn too far, the matte band goes from the very start here to the very finish there, and you're not after that. Yes, it will run, it will be okay, but it's not ideally the seating you're looking for, and it won't give you that good seal. You think you've got more of a seat, but in fact you actually haven't. It will pass easier due to the surface area and the pressure. So that's what you're looking for, a nice matte band all the way around with no pitting. And the same on the seat. So this is ready to go together now. I'm going to just get some acetone round here and just make sure there's no remnants of grinding paste or anything of the sorts, and then we're going to reassemble the valves and the head. You'll see on the flywheel, I've put the key in. You've seen that new Woodruff key go in, and this is just gently tapped down. We're still waiting for oil seals to come for the oil pump and the springs for the clutch, so we're going to move on to this, save hanging around. So you're looking for the letter T, okay, not the fire, F, the letter T, top dead centre. Follow that line along here and you'll see a line on the casing just here, that little nick. You need to line those two up. The letter 0 on the cam wheel, you'll see is, I'm guessing at the moment, I'm going to say a tooth out. That 0 needs to line with that cut there. So this is the fiddly bit now. Undo these. Move the flywheel one tooth, hopefully. Get that in as quick as you can. So you'll now see the 0 one here lines up with the cut there. That little 0 showing up. There's a 0 there showing up with that cut there. And the letter T here, that line there is lining up with that mark there on the casing. So just bearing in mind we haven't got the tensioner adjusted yet, so there will be a little bit of play in it. So 180 degrees out, the 0 is there. And then back round to timing, and the 0 is there. And what we'll do, as a precaution, just wrap a bit of tape round there to keep the Woodruff key in. So, where's that tensioner pulley? For tightening the tensioner up, you've got a flat on here. Make sure that flat remains at the top. Just for now, we'll put in, there's a new O-ring on there and a bit of grease. Just put the cam chain tensioner locking bolt just loosely in there for now. We'll come back to chain tensions in a bit once we've got it a bit more together. And we need a copper washer to go on there. Got a new O-ring there, new O-ring there. back of the stator plate, push a new seal in. The O-ring round the outside is also new. Okay, so that's the stator plate back on. I have used countersunk Allen key bolts rather than the pan screws that were in originally countersunk screws, Phillips head, whatever you want to call them. The reason for that being, you can see the state of that bolt. That was an absolute nightmare to get out. So it is drifting from the original engine build slightly by using hex Allen key bolts, but I'm not having that trouble again. That was a nightmare, especially next to electrical coils like this. You've only got to slip and you've scrapped a 6-volt coil set, which are quite hard to come by now, so that's why I've put those in. Okay, we've popped a new set of points in. That's been done. The sponge has been cleaned. It is the original and lightly oiled in some very thin oil. Emphasis on the lightly oiled. I've cleaned up the coils with a tiny bit of very fine, in fact 40 micron sandpaper, so I've used that. The flywheel has had its magnets lightly cleaned up with the same sandpaper, and a small amount of oil with finger has been applied to keep them clean. Again, not an excessive amount. Interestingly enough, on this flywheel, the advance and retard, or shall we say just the advance spring retard system was seized. It is now freed off. Well, inside there it looks like water, and judging by the magnets has got inside, and this wasn't operating. So this was just done by penetrating oil. In fact, I soaked the whole thing in penetrating oil, and then this has just got some chain lube on it off a motorbike, just a small amount on the pivots because it's sticky and it dries, and so it won't be flinging off against coils and everywhere like that. So there's some down inside there where it pivots against, and then on these points here. So that's what the slight sheen is. So that's all nicely freed off now. That just simply advances and retards your ignition in respect to your valve timing by moving the cam lobe to a different point for the points to open. As the revs increase, the centrifugal force simply throws this out, which rotates the lobe. Okay, and that will advance in relationship to the timing of the engine. So what we're going to do now, that's also got a light amount of engine oil on it, so we're going to pop this on now, making sure that we move the points out the way so we don't hit them against the lobe. Okay, gently with a screwdriver, we're just going to lift the points out the way, and there we go, it's dropped down. So we're going to move on to setting the points clearance and the valve clearances. Just a quick one, a good way to check if your chain's worn if you can pick it off the back of the sprocket at 1 o'clock, 11 o'clock, 12 o'clock, then either your chain or your sprocket's worn. Tension on here that I've put on is not excessive, it's just, you can just about move it without prise. Line the lug here with the lugs on there, so that one at the bottom, and then do your inspection cover up. The tappets are really easy to set on this, so this one's miles out at the moment, loads and loads of play. Set it to T, so T on the flywheel lines up with there like we did with the timing, and it must be top dead center of the compression stroke. So you're not looking for the exhaust stroke, you're looking for when the fuel's in and everything and it's coming up and it's compressing. So the top of the compression stroke is what you're after. So tooth feeler gauge, just for super authenticity and keeping things original, as I have done on the bike and the engine, we're going to use the proper tool, which is totally unnecessary because you can do it all with your fingertips. There is another tool that like a socket that this will go over and it grabs that, but I can only go so far with spending money on things I don't really need. So wind this in until it touches. So that's touching now, that's no play at all. Get your tooth out feeler gauge. Put that in there. Right, what you're looking for is a good feel on that, so you can see, not resistance, resistance isn't the right word, but you know it's touching. You don't want it to flap around in there. And there you go, that's a nice feel on there. So that's that tappet set, and I've already done the other one, and the cover's back on. For setting the points, stroke, contacts, stroke, breaker tips, well, whatever you want to call them, this is how you do it. So you rotate the flywheel until you see the F is approaching that mark there. Okay, when the F is approaching that mark there, there's your contacts in there. The F is now approaching, and you will see a gap has appeared in those two round sections of brass there, just there. A gap has appeared. If you continue to rotate, it will get slightly bigger. There's, you can see it good there. This will break the circuit and send the current down the spark. You will see here now there is no gap at all between those two tips. So back round, and there's the gap. You can see it coming there. See it opening and closing. Okay, so that's how you do it. So you want it to be on F, should, when it start to open, not be fully open, and you adjust that screw there, that one there, with some feeler gauges in, and you have a range of 12 to 16. These are currently set at, I've wrote it down, these are currently set at 14, so smack bang in the middle. How I did that is, I don't tend to use a 14mm feeler, because by the time we tightened it up, I went in with a 16 thou feeler, and once you've tightened it up, it ended up at 14 thou. We are going to check the timing once this engine is back in the bike, in case we have to fiddle with it a little bit, and we're going to use a timing strobe, if I can remember how to get it to work from my A series mini days, which was about 20 years ago. So if I can get the strobe to work, I'll show it you setting it up with the strobe, but either way we need a gap in there between 12 and 16 thou. You have got some slight adjustment on the timing as well, but only very slight. So on F and rotate, largest point, so about there is your largest point, and that's when you set it, just so you can get to the screw. To quickly explain the clutch operation, I can't remember who asked this, but I'll do my best to explain. This pinion here is totally independent of the crank. The only thing it directly connects to is this wheel here, which then drives onto your prime shaft of the gearbox. So that's the two that are only connected. This can spin freely, the crank, without driving anything. Okay. This here has a series of cuts out of the steel, which locates onto only a small section of that gear there. So that's as deep as that will go. Only drives on that edge there, you can see the marks. Here we have a series of 8 rollers. These 8 rollers, when it spins round, i.e. the centrifuge, forces these rollers outwards. And as they come outwards, they rise. If I hold that one there, you'll see how much that one has risen up. See the distance there. In comparison to the roller next to it, which I've pushed back down, and it is practically flush. So from that, which would locate onto there, this sits onto the ring that was broken when we stripped the engine down. This is obviously a new one. This sits in those grooves there. So that angle there sits in that angle there, and this gives us a lift operation. As it rotates, it lifts out. So on with the rear pressure plate, that goes in there, this goes in there, you'll see there is the splines in here. Those go onto the crank. So now you can see what connection we need. We need a connection from this to this. Currently that's 3. So building the clutch up, we need a friction plate to go face down. Then a 2-sided plate which locates into these pegs here. Can't go into there. And then another friction plate, single-sided. And then finally this plate. We've just got to put our new springs in, which is what we've been waiting for. So there's part number with 4 new springs. Now it's gone to there. So what we actually have now is a sort of connection happening. There's your crank there, which is fixed to this here. That now is sandwiched. The outer of the plates, the ones with the non-friction material, are engaged into this. The inner of the other plates are on this. So you can see now we do have a multi-surface contact between these and those. What will happen when this spins, those rollers will rise out and they will lift this. Okay, they will lift the plates there against a circlip which we haven't yet put in. When we lift this, this will also rise. How I showed you before between the two, see that rising? So not only will we have the rollers assisting, we will also have this, which is bringing the plates together even more. And it creates like a locking effect as well, in a way, that the rollers are pushing, and this is also giving the rise. So as these two come together against this plate here, okay, I won't be able to show you once we put that circlip on, but as these two come together, it clamps this whole assembly together. So these plates are all together now, are as one, connecting the inner to the outer. That is connected directly to that. That connects directly to that gear there. So now we have made a solid item-ish while it's rotating at speed. So let's make sure I put all 4 springs in. Yeah, I did. So that's that assembled. Get yourself a little G-clamp. There's no need to go mad squashing this lot together because it don't take much to get it below the surface. And what we seen earlier was the 4 springs which are in here, 4 very large springs which are on these points here. When this all locks together, this is like your taker up of the play, should we say? I mean that's bad terms. And here we've got these that just take up your slack play, so you don't get like clutch chatter and things like that. And that's basically how the clutch works. It just compresses itself with speed by the spiral effect and also the rollers. And then we have the 4 big springs which just all lock it together and take up that movement. There we go. We're going to pop the circlip on now. there's your clutch plate assembled. This is a standard clutch. Actually that is still turning, that's good, so I can show you. We have a new tab washer. Got a new valve wheel washer. Preload washer, and it's also marked outside, so it must go like that in there, not like that. And then finally the nut. What's very convenient, probably more than when we were taking it apart, we need to tighten up the flywheel, and we also need to tighten up the clutch. The flywheel is 25 foot-pounds and the clutch is 27. So we can use the clutch assembly to tighten through the crank to tighten up the flywheel. So simply get your socket, the correct one, put it onto your flywheel nut and torque up this side. You're tightening this one at the same time. Torque up this side till it gets to your 25 foot-pounds, and then as we did when we took it apart, use your peg spanner on these two holes here to do the final torque of another 2 foot-pounds to get up to your clutch. I think we've got that roundabout aligned. Yep, so we can knock this tab washer in now. There we go, that one's in. So that's all locked up on this side. That side's all nicely tightened up. So the next thing to do is the filter gauze, and I want to modify the sump plug. I've got some old magnets. They're new, but I've been carrying them for many years. I've got quite a few of these. They're out of an A series engine sump plug, and what we're going to do is we're going to drill out the centre of this and put that in there, just like an A series sump plug really. This gives us a good opportunity to see how far we can go, that we don't block up the inlet port here for the oil pump, because it's directly in line, and what we could actually do would be to shove that in there, and that could create us all sorts of problems. That's okay with that plate in place. New SKF bearing. You'll see that's on an eccentric style cam, so the hole isn't in the centre. Put that into there. And you got this little spring that goes in there. Then this with the form section going downwards, so it locates in there. Got a new strainer for the oil, it's tapered, so make sure you put it in there correctly. This is the finished sump plug, just give it a little bit of zinc paint on it. Quite a good strong magnet. And you'll see when this is fully tightened with a washer in, it's not going to touch the strainer. If this was by some chance to come out that magnet, it would only touch the strainer anyway, so it couldn't actually come out of there altogether. And even if it could come out of there altogether, it's not going to come down to the hole there or around the casing and into here. You just can't do it. So it's a very safe mod, providing you do it the right length. So I'll just find the correct washer. It's going to be one of these two. It's going to be that one. Yep. And there we go, all locked up. There's still clearance between the magnet and the gauze, so it's not touching anything. And like you can see from there, it can't come out the sump plug. Even if it could somehow, it ain't going to get out far. You may remember way back when we discussed how this had been butchered and we rebuilt all the manifold. Okay, well, this is the original piece that's been butchered. We need to hopefully use as much of this as we can, trying to keep it original. We need to mount this about here, and this bracket would be bent the other way, and it would come along here and it would fit onto here. Goes around this side of that aluminium, but it's also at a slight angle like that. So we're going to fabricate this bracket now and put it back to how it used to be. If we look at this here, that's what we're going to try and make, is that bracket there. If it ever focuses. And try and make that bracket there. That's what currently remains of it. So we've got a fair old bit of work to do. We've got to fill a hole up here and make this at the back. We've made the separate components now to the bracket. So this obviously goes onto the carb. This here has got a curve in it like the original would have, and that goes onto there, like that. It gives it some strength, because if that was just a piece of flat stock it would flex a bit, just like the original had the curve. Then we've done the same with this, and then this will go on here somewhere, but this needs fettling at some point. So there we go, we're going to stick all this together now, like that, and that ain't far off the original bracket. The throttle Bowden cable bracket is now complete. Looking at the drawing, I've tried to get these angles the same, that angle there and then that angle there, so it comes down in line with the butterfly of the carburetor. I think that's as close as I can get it off the drawings without definitely knowing physically what it looked like in my hands. We seem to have some marks that have appeared here. This happened when this was red hot and I was forming it in the vise, and there's some weld splatter on the vise, and obviously I've punched it through into the steel, but we can live with that. I'm not stripping all this down again. You couldn't really see it until it was sprayed. So there you go, that's finished now. The inlet manifold just had a spray. Okay, you remember from the earlier video, this was all resin bonded in, and I just thought I'd give it a little spray over, clean up the mating face. So we're going to do very little on the carburetor actually. It started as from the previous video, but we're just going to do some basic checks. Parts for this are very, very scarce now. The O-rings that I have changed are just common sized O-rings. This is your fuel drainage for the bowl. That's a new O-ring. Float's the original. The jets I've just blown through and cleaned. This is off the bottom of the fuel bowl. That's just a new metric O-ring. That in there is a new O-ring as well, or more should I say, a flat washer. And that is about it. There's not really a lot else you can do with this. So what we're going to do now is blow it all through, check all the jets, set the jets as per the manual, and also set the fuel float height. The float's in particularly good condition. There's no damage, there's no holes in it, doesn't appear to be any cracks in it. There's some weird lines around here where it's just been sat in fuel for a very long time, but there's no actual damage for that, so no leaks or anything of the sorts. This is the float fuel shut off. Just checking the rubber for the top to make sure it's okay, which it is, which is just as well because I can't get a new one. And then also check the seat inside the carb, which this goes into, is in good condition. This one had a lot of fur and gunk in it, which I've just cleaned up with a kids straw brush. You know, you clean straws out for kids. That gets in there a treat, and cleaned all that up and blew it through. Then put the jet back in. Right, put this onto here. And seat that in there. So that's in there now, it's free to move. So we're going to set the fuel height now, fuel float height. To set your float height, get your calipers or whatever you choose to use, and it's 30.8. You measure from the top of there to that point there that holds the float. So don't do it at this angle obviously, but I'm just trying to show you on camera. Put its arse there and then touch the tip onto there, and you can see this one is near enough close, but I'm going to now do it in the vertical just to make sure. Should have no pressure applied to there or no lift applied to there, just let it sit naturally. Yep, that one's good. So that's with the jet in and everything. So that part's now finished. The main jet's just been cleaned. I used the welding nozzle cleaner. Be careful you don't start filing it out, but just that was block solid obviously, because when I block solid it was very small, very restricted. So just give it a little clean out. Screw your jet back in. Sit your float onto there. And what we'll do now is actually put the fuel bowl on. Once you've put your float back in and your new O-ring at the bottom, I'm going to put the fuel drain screw in there. This is your pilot jet. To set this up as per the manual, screw it in all the way till it stops. It won't be a fully compressed spring if you've got the correct spring on. Don't go in too hard because you'll damage the end of the jet screw, sorry. And then simply unscrew it from in 1 3/4 turns. So that's 1, 1 1/2, 1 3/4. So that's 1 3/4 turns out from fully in. That should be a nice starting position. We then have got to tune it once the bike's warmed up and we've got the air filter on and the exhaust on and all that business. The seal was missing at the top of the carburetor, so I've just made one with a little punch and an old inner tube. This is the inner tube that come with the bike originally, so that should now fit perfectly in there. So this is fully assembled now and all ready to go, all locked up. Right, this cover can now go on. We've been waiting for this part to come here. The original engine, which is that one there, which is like a collar with a top hat arrangement so the spring can't come all the way through. The engine on strip down didn't have the collar here that goes into there. That goes on top of there, and then that goes on there. This thing goes here. Screw that into there. At the moment that's fully screwed in. We may have to adjust this in a bit, but that will sit there. Like that. And what this simply does is help to release the clutch. And that's all it does. When this moves, the gear lever, that turns that. This is stationary. Those balls will be there, and what it does, it splits the two like that. Okay, so you get greater distance between that there and that there, and what that does, it pushes this clutch in, and that helps it to release. It operates the big springs, if you remember the big springs, it operates those, and it will push that in, and yeah, it will just make it a lot easier to release. We had a problem when we took the loom apart. For those of you who followed this from the start, firstly I thank you. You got good staying power. This part of loom was very hard, and I had to replace sections of the cable. Now this part of the loom is above the hottest point of the engine, which is the block. So I've got some of this that I used to use on other old motorbikes when I used to do up, and we're simply going to fold that around the loom. It is proper heat shield, very high temperature, and it proven itself a number of times to me. It is very good. So we're going to try and just protect that little bit of pipe by wrapping that round. So that's just put round the loom and just cable tied in place, not actually stuck to it. It's just to protect it. So we'll put it back in its clips, and that should be a bit more heat resistant, because there was quite a bit of damage to that insulation, and it was rock hard, and it was even affecting a couple of the copper wires as well. So I think that's covered all the hot areas. The spark plug is currently removed. The engine's all fitted. There's oil in it. I think it's still in gear. What I want to do, because it was a dry engine, is I'm going to run this on an electric drill. As said, the spark plug's off, the fuel's off, and we're going to look down the inspection cover for the tappets, and once we see oil in there, we know that the oil pump is good, and well, as best as we can tell, because there's no test points. So we're just going to run this up until I can see some oil coming out of there. Okay, no bits in that, looking good. So we know the oil's feeding through good and proper there. So I'm going to put the spark plug back in now, turn the fuel on. And give her a little try. We are running it without an exhaust, so I won't be running it for long. Just make sure it fires up, and then put the exhaust on and set the timing and the mixture. Prior to checking the timing, we need to ensure that the engine's running at idle. If the engine isn't running at idle, it's going to advance the ignition, and that will give you a false reading. So idle for this engine, according to the manufacturer's data, is 1300 RPM. This is quite a smooth engine after its rebuild, so I'm hoping we can get her to idle around the 1300 RPM. We're going to check it then, see what we got, and then if necessary make adjustments. But first of all, we need to check the speed. So I've got on here a fluorescent material and this cheapy eBay meter. So we're going to try and get her to 1300 RPM if she isn't already around there. Right, 1350, shall we say? So we can check it at that, it's not that far out. And how we're going to do this is to narrow the gap in the points. At the moment they were set quite large on the upper end of the allowance. Reducing the gap in the points on this design will actually make it open less early. So we'll be able to bring that F from here, fire, do a bit more here. So let's try this again and see where we are.